Part B, if weight 10 newtons lies at rest in equilibrium on a rough plane inclined at theta to the horizontal. A horizontal force of magnitude 2 newtons acting above a line of greatest slope is applied to B. See diagram. Complete the diagram. So we can have a force going down because of the weight. And I normally just write the number, but because they've written newtons, I think I'm going to here as well. Then there's something that stops the weight just going like falling, and that's actually the ground, and it's called the normal reaction. It's going to be at right angles to the slope, so we need to add that. I'll just call that R. And then because the plane is rough, at the moment the block would just slide down the slope, but there's something that's going to try to stop it, and it's going to be parallel to the slope going this way. So I'll label that capital F R. You can use other symbols if you want, but these are quite often used. Um, and yeah, that's my answer. I could draw in that that is theta because I'm going to be using that in a minute. The reason is that I could create a right angle triangle here. That's 90 minus theta. This is 90. So then we get back to theta over there. And I could also, if I just draw a line going parallel to the slope there, this is also theta because of alternate angles. I've got a Z going on here essentially. It's given that B remains at rest and the coefficient of friction between B and the plane is 0.8. So that's our mu. Now, the friction is less than or equal to mu r. That's a formula that how you can get the friction from the normal reaction. So for us, it's going to be Fr is less than or equal to 0.8. By the way, you do get away with doing an equals in this question, but technically speaking, it should be less than or equal to, because friction only needs to take a value big enough to stop movement. It won't go beyond that. So if you push a heavy object, it's going to push back at you with the same force. As you increase the force, the friction is going to increase as well, just to match you. It's not going to sort of start chasing you or anything. Friction's not going to overcome you and have a box kind of start like moving towards you. So it's always less than or equal to. Okay, we've got that. Now let's resolve forces. First of all, I'm going to look perpendicular to the slope. Now there's R acting perpendicular to the slope. There's also a component of the 2 Newton force because I could draw a component parallel to the slope going down it, and then this one here that's perpendicular. And what we're going to get is that it's 2 sine theta because it's opposite the angle. We could call this x if you wanted, and then we could write down sine theta is the opposite, x, divided by the hypotenuse 2. You could rearrange that to see that x is 2 sine theta. It's something to get used to. If it's opposite the angle, it's going to be the sine component, and if it's next to the angle, then it's going to be the cos component. And then that is going to equal 10, but then I need to split that into components as well. There's a component going this way and then one this way. This time it's adjacent to the angle, so it's actually going to be 10 cos theta. So that means that r is 10 cos theta minus 2 sine theta. We're now going to do forces parallel to the slope, and I'm going to get an expression for F, and then I can put it all, I forgot the R here, sorry. I can put it all into here. So now I'm going to resolve forces. Let's go down the slope. Doesn't really matter, just it's just parallel to the slope basically. So then I'm going to get 2 cos theta for the component from the 2 Newton force plus 10 sine theta because it's this one, the one that's opposite the angle, and that is going to equal Fr. Okay, we can bring this together now. So it must be, so therefore, 2 cos theta plus 10 sine theta. Actually, I'm not dividing yet. So that is going to be less than or equal to 0.8 times 10 cos theta minus 2 sine theta. And essentially, we want to get tan theta somehow. Well, I'm first of all going to multiply this out, which will give me 8 cos theta minus 1.6 sine theta. And then I'm going to add on 1.6 sine theta to both sides. So I'll get 11.6 sine theta. combine the like terms essentially. This is going to be less than or equal to 6 cos theta. Now, it should be noted that theta is going to be between 0 and 90. So sine and cos are going to be greater than 0. So it doesn't matter if I can divide by cos theta without having to change the sign, but it is always worth thinking about that. So that means that sine theta over cos theta, which is tan theta, is going to be less than or equal to 6 over 11.6. I've just kind of, instead of cross multiplying, cross divided, divided by 11.6 divided by cos theta. And if you put that in your calculator, actually it becomes 15 over 29. Okay, is a nice fraction. So tan theta must be less than or equal to 15 over 29, which means the greatest value is going to be, greatest value of tan theta is going to be 15 over 29. And that's why you kind of get away with the equals, because it ends up being the equals 1. But it's just worth knowing that it's not necessarily equal to it. That's just the maximum value. It has to be less than or equal to 15 over 29. And if it was lower, then you'd have a smaller angle, and you wouldn't need as much friction to kind of keep it from slipping down the slope. But as the slope gets bigger and bigger, the angle gets bigger and bigger, you need more friction to stop it slipping down. And if it went beyond the angle that you get from solving tan theta is 15 over 29, and actually we wouldn't be able to get enough friction. It wouldn't be enough, and wouldn't be in equilibrium. It would go down the slope. But here it's okay. Tan theta is 15 over 29.